Alright, example 5 is now asking us to write the equation of a tangent line to the parametric curve. Alright, so just like before, just like any other problem we've done, in order to write the equation of the tangent line, I need an x, I need a y, and I need a slope. And so we're going to use the equations they gave us to determine those values. So the x-coordinate will come from plugging in the t value into the x equation. So I've got x is equal to 4 times the cosine of 3 pi over 4. So 4 times cosine of 3 pi over 4 is negative square root of 2 over 2. Simplify, we get negative square root of 2. Just kidding, negative 2 times the square root of 2. So negative 2 root 2. So to get the y value, we're now going to plug 3 pi over 4 into the y equation. So we have y is equal to 3 times the sine of 3 pi over 4, which is equal to 3 times a positive square root of 2 over 2. Nothing simplifies here, so we just have 3 root 2 over 2. Alright, so now to get the slope, we are going to first take the derivative, and then we can evaluate the derivative at t equaling 3 pi over 4. So remember, to take the derivative, we need dy dt, and we need dx dt. So let's start with dy dt. So dy dt is just going to be the derivative of y. So derivative of sine is cosine, so we've got 3 cosine of t. Dx dt, derivative of cosine is a negative sign, so negative 4 sine t. So the derivative is just going to be the dy dt divided by dx dt. So we have dy dt is equaling to 3 cosine of t over negative 4 sine t. And now what we're going to do is we're going to evaluate that at t equaling 3 pi over 4. So we're going to do dy dt evaluated, not dy dt, dy dx, and this should also be dy dx. So dy dx evaluated at t equaling 3 pi over 4 is going to be equal to 3 cosine of 3 pi over 4 divided by negative 4 sine of 3 pi over 4. So what we have is 3 times the negative square root of 2 over 2 divided by negative 4 positive square root of 2 over 2. My negatives cancel, my root 2's over 2 cancel, so we're just left with a slope of 3 over 4. So now we're just going to write an equation in point slope formula. So y minus y1, so minus 3 square root of 2 over 2, is going to equal my slope of 3 over 4 times x minus the negative is going to be plus 2 square root of 2. So that takes us to our last example for today. So this is asking us to find all points of horizontal and vertical tangency. So when we find points of tangency, it needs to be an x, comma, y point. So make sure that you're doing x, comma, y. So we'll solve for t and then use that t value to determine the x coordinate and the y coordinate. Now, so what we're ultimately looking at is tangents of dy dx. And remember, dy dx came from dy dt divided by dx dt. Now, horizontal tangent lines means that my slope is equal to 0. So horizontal, my slope is equal to 0. So to make that slope equal 0, that means that for the horizontal, then we want the numerator to equal 0. So we're going to say dy dt is equal to 0. Now for vertical, we want my slope to be undefined. And to make my slope undefined, that means for the vertical, then I want the denominator to equal 0. So I want dx dt to equal 0. And so that's what we're going to do. To find the horizontal, we're going to set dy dt equal to 0. For vertical, we set dx dt equal to 0. So let's start with the horizontal. So first, let's find dy dt. So I've got dy dt is going to equal, so just a power rule, so 2t minus 3. We're going to set that equal to 0. And so we get a t value equaling 3/2. Now what we need to know is when t is equal to 3/2, what does x equal? And when then t is equal to 3/2, what does y equal? Right, so we're just going to say x is equal to, I've got 3/2 squared plus 3/2. This is a no calculator type of problem, so you would be expected to do those fractions. We're going to end up with 15 over 4. And we're going to do the same thing with y. So y is equal to, I've got 3/2 squared minus 3 times 3/2 plus 5. We're going to do that, and we get a y value of 1/2. Now it asks for the point of tangency, so we just need to write that as an ordered pair. So we have 15 over 4, comma, 1/2. Alright, so that's my horizontal. Now we're going to go through all the same steps, just with dx dt equaling 0. So I'm going to find dx dt, which is equal to 2t plus 1. We're going to set that equal to 0. Don't forget that we need to see that step where you're setting it equal to 0 on your paper. So we get t equaling negative 1/2. Right, so we're going to take negative 1/2 and plug into both the x and the y equations. So we have x is equal to negative 1/2 squared plus negative 1/2. And we're going to get an x value of negative 1/4. We're going to plug into the y equation. So we've got negative 1/2 squared minus 3 times negative 1/2 plus 5. If we do that math, we're going to get 27 over 4. And remember that we need to write that as an ordered pair. So I've got negative 1 over 4, comma, 27 over 4. And so that will be my point for the vertical tangent.